What's going on out there? 455 Pirate Radio, 766 Pennsylvania saying hello. How about that needle bender 9250 in the diesel wagon? Do you copy 766 Pennsylvania?
766 Pennsylvania. Got a fine copy. 6 Pennsylvania. Don't you do those YouTube videos? In this diesel wagon, Tennessee 73.
128, I got a good signal on you. How you doing this morning?
I thought that was you. Yeah, I watch your videos all the time. They're really good.
I appreciate that. It's definitely good to hear you in there. I sit here and listen to you every day. All right, YouTube. Hello. Thank you for watching. This is an update on the ddsvfo I've been working on here for quite some time now. It's really gotten to the point in which I had to bring in another person on this ordeal to see if he could wrap his head around this as well. So I have my friend from DTB Radio involved in this project also, and we're kind of putting our heads together to see if we can't figure out what's going on here with these ddsvfo boards. So this is the replacement board that Toby had sent me. I just received this board about a week ago and got it all installed. And, I just don't know what's going on with this board. It's really become quite a remarkable problem. Honestly, I've been kind of dragging my feet on putting another video on until I give Troy Radio a chance to respond to see what Troy Radio is going to tell us on this. So there are a few things that I can kind of go over here, but there's really not a lot I can say at this point because I still don't have a fix for this. The issue still remains the same here, that in the menu we're missing items number 15, 16, 17, and 18. And those are all offsets for USB and LSB here on 17 and 18. Without those offsets being programmed into that menu, it remains the same. That the only way you can get this to operate on SSB is to shift your clarifier, because there's no offsets in there for the microcontroller to do it by itself. I'll show you the items that are missing from the menu. If you go to the settings menu, this is number 1 of 30 in the menu, and then you scroll up through. When we get to number 14 right there, 14 of 30, you see what happens. There's no 15, there's no 16, there's no 17, and there's no 18. It skips to menu number 19. And all those things that it skips are the things that I'm saying I need in order for this board to work on upper and lower sideband. And as I said before, those are things that have to do with SSB offsets. Number 15 is labeled as intermediate frequency deviation and transmit. Number 16 is frequency deviation for AM. And 17 and 18 are labeled frequency deviation for LSB and USB, which in parentheses they say the offset for when the system is in LSB. And that's exactly what we're missing, is the offset. Like I said, I'm waiting to hear back from Troy Radio on this. But if you have any idea why items 15 through 18 might be taken out of this menu, please let me know. Kind of big ditto, same as before with the other board. So that is the $1 million question there. We're just not sure how this can be. This is the second board. So just a couple things that I do know here. This was the old board that was in it. They made some changes on their boards. Other than the obvious surface mount, I was told that this board here is exactly the same as this board. But I guess it goes by what someone's definition of exactly means. because I take exactly pretty literal, but this board is not the same as this board. I mean, for the obvious reason, they changed the regulator on this board, I can tell you that much. This is a 5-volt regulator that's on there now. On the previous board, it was running off of this 78L08 here, so it was an 8-volt regulator. So that is different. One other thing I have noticed too that kind of raises some eyebrows with me is there's a little tiny chip cap down here, and I just kind of rang him out on continuity. It looks like it sets across the SDA line here, which is this white wire right here, right beside that black with a blue tracer on it that's ground. So that cap is actually setting right across there. You know, you might be thinking, well, what's the significance of that cap? You know, and that's a good question. But I can tell you this much, that cap did not appear on this board here across those 2 points. And I don't know, it would make sense to me, this may relate back to the buzzing problem that I was having on this unit. That's the only thing I can really come up with. But, you know, don't quote me on this because, you know, I've only been messing with these boards here for like probably the past month and a half. Maybe it was a fix for something, I just don't know. But the reason I say that is because in this 33 pages of information that came with it here, there was some talk about noise on lines and things of that nature, and the word capacitors was brought up somewhere in here in these papers. Now, it didn't specifically say anything about this exactly, but it kind of sort of sounds like it was very much related to this, if that makes any sense. That's why I say it kind of raised eyebrows with me, because this unit had a big buzzing problem. So the strange thing is, we no longer have the buzzing problem. But like I said, unfortunately, this unit still does not work, and it seems the reason it does not work properly is because there is something that is not programmed in. Specifically, those items that I mentioned to you makes all the sense in the world. Kind of skipping away from that whole thing, looking at the buzzing problem. Well, the buzzing has went away on it. I do hear a little tiny bit of hum, but it's just hum. It's not anything like it was before. On the old board, when this OLED display would power up, you could definitely hear a significant increase in the buzz. Now, I can hear the hum myself, but I don't think the camera's going to pick it up. But the camera did pick it up before on the previous board. I don't think that's really going to be an issue anymore. So the buzz has went away for all intents and purposes. You know, the thing is, you know, I have an inquiring mind. I mean, why did the buzz go away on this? You know, you might think, well, who cares why the buzz went away? Just accept it. But, you know, there's got to be a reason for everything. Now, when I reran all these lines here, I shielded the cable on all these. So my cable going up to the LCD display is shielded. My cable going to the encoder is shielded. And my cable back here going over to the oscillator is shielded. So it makes sense to me, just from my perspective, that it seems quite reasonable that it could be any number of 3 things that made the buzz go away. It could be something on this board is different. I mean, other than the obvious SMT, you know, it could relate to that capacitor. It could relate to the wires being shielded. You just really don't know. The logic on this board, I will tell you this much, because this was something I went through here. I pulled my hair out on this, and it wasn't obvious, the answer. And that is the transistors for the mode switch here are on the underside of this microcontroller board. So when I first looked at this, I thought, well, where's the mode switching at? Because the mode switching transistors were all in here. And what I had thought is that they took those away and didn't use them on this board. And that frustrated me because I thought I was going to have to redo my mode switch all over again. But that's not the case. The transistors are on the underside. You just can't see them. So the mode switch stayed the same. So when we go into USB, this orange goes high. When we go into AM, this blue goes high. And when we go into LSB, if you want to call that default, neither of these go high. Had anyone really looked at this board, there would have been no way or no indication to them that was even remotely obvious that those transistors were hidden underneath here. Now, I didn't change anything on this board at all. It's exactly the way it was before. It's got a 330 up there. The 47 ohm is down here for the RC, filtering on the 5-volt line, which is actually on this red wire here. It's a piece of number 22. The SCL and the SDA lines, and I'm an idiot when it comes to this. I have no idea what those lines do at this point yet, but both of those lines are completely shielded with this piece of cable right there. Now the shield is actually not attached up here. I pulled the shield back and it's sitting on top of a piece of heat shrink here with that tie wrap around it. So the shield is just, for all intensive purposes, floating. This one here, the shield is connected on the encoder. It's connected to the ground here on the encoder. So the top and the bottom of the encoder, which are the white and the red here, are shielded. The push button switch, which is this leg right here, is on this white with a black tracer. Now on the oscillator, the shield is grounded at the board here. And then of course the SCL and the SDA, the white and the red, are shielded here. But the shield is not connected on the other side of the board. It's just kind of floating there. The reason I left this shield float up here was sometimes you can get ground loops when you ground things at multiple points. Didn't seem like a good idea to have this shield grounded up here, but the ground wire for the display, for the OLED display, is right here. And generally what I do, which always has seemed to be pretty good practice, but you know, it does depend upon what you're doing, is shield at an input but don't carry the shield through it in an output, if that makes any sense to you. So in other words, connect the shield to ground at the input of the board, but leave the shield float anywhere where you could basically say it's going to be an output of the board, if that makes any sense. Now I left all the voltage regulators the same, and the oscillator is still being powered by the 5-volt regulator that I built over here beside where the PLL was. This is the cable I used here. This is Gotham cable. Anybody that's been into pro audio probably has heard of Gotham cables. They're a real good company. This is 10301 cable. They call it GAC2, GAC2, I believe. There's actually 2 layers of copper that are wrapped around this pair. It's pretty small, it's pretty flexible, until a big booming voice comes down from the sky and says, this is the answer to what's going on. I mean, I can understand this happening on one board maybe, but it just doesn't make logical sense that 2 boards could have this problem. Now I will say one thing here, that seems to be very consistent. This crystal frequency adjust, it was almost identical to what the first board was. I had to shift the oscillator, the 25 meg crystal, and how this is done, I still can't make sense of it, but I had to shift it by 3.44 kilohertz to set this radio on frequency. It says 25003440. I do hear the hum pick up just kind of like the old board was, when the OLED display becomes more active, when there's more pixels lit up on it. So the thing remains the same as before. If you want LSB, you turn this to LSB, and then turn your clarifier the whole way to the left. And if you go to USB, you just flip it up there, turn your clarifier 2.5 kilohertz to the right the whole way to the very end, and then you'll be able to transmit and receive on upper sideband. That's exactly the same as what it was. Honestly, I'm almost inclined to say the hum at this point, or the buzzing, actually, probably more accurately. I would say this is probably at an acceptable level right now with me, the way it is. I think some of the hum that I'm hearing might be somewhat magnified to a small degree from the power transformer itself. But it's definitely still OLED hum. But when the radio's setting a couple feet away from you and you have, basically ambient noise around you, I don't know that it's going to be a big, huge problem like it was before. Anyway, so I appreciate you taking the time to watch my video today. You take care and have a great day.